Welcome to the Backyard Professor Math videos. I want to review a couple of brief properties real quick with you in algebra, just to make sure we understand them, and then I'm going to hit it really hard with the most important property that we are going to use constantly in algebra, trig, calculus, and beyond. So let's do a quick review. Now, these other properties are not unimportant. Don't get me wrong. I'm not trying to de-emphasize them, but I want to focus exclusively on the other part because it is used so extensively, because it works so well in having us solve real-world problems. When we get to learn word problems, we will be using these properties, right? So the basic property is any number or variable f plus 0 is the exact same thing as 0 plus f. It just equals that number f. Anytime you add 0 to any number, it doesn't change that number. 99 plus 0, 99. 35.2 plus 0 is 35.2, right? 0 doesn't change it. And with adding, it doesn't matter which order you add something. You can add 3 plus 4, or you can add 4 plus 3. It's irrelevant what order you add, right? Same thing with multiplication. G times 1 is the same thing as 1 times G. It simply equals that number, G. 3 times 1 is 3. Well, 1 times 3 is 3, right? 14 times 1 is 14. 1 times 14 is 14. This is the idea. So if x plus y, if it equals 4 plus 7, then it's also true that it equals 7 plus 4, which is just 11. Either direction of adding gives us the same answer. With addition, right? Whether it's variables or actual numbers, it works the same way. Isn't that nice? It's kind of nice and consistent. So we're not going to get goofed up and lost if we're working with nothing but variables as opposed to numbers, or with numbers as opposed to variables. It's the same thing in addition, adding any direction. It's the same thing with multiplication. X times y is the exact same thing as y times x. 4 times 7 is equal to 7 times 4. Both of these expressions equal 28. Now with the associative, 3 plus 4 plus 2, we put the 4 and the 2 together in our parenthesis to tell us that these two are going to be grouped together. And 4 plus 2 is 6. So this 3 plus 4 plus 2 is really 3 plus 6. But we also know with the associative of addition like this, the order, the grouping doesn't matter either. It doesn't matter if there's only 2 terms or 3 terms or 93 terms. We put 4 and 2 together here. Well, if we put 3 and 4 together in the parenthesis plus 2, it's the same 3 numbers, 3, 4, and 2, and 3, 4, and 2, but this one equals 3 plus 6, and this one equals 7 plus 2. But they both equal the same number, 9, right? This is the associative principle of addition. And it works the exact same way with addition as it does with multiplication. 3y times x. Now you group 3 and y together and then multiply x. This is exactly equivalent to y times the group of 3x together. This is y times x times 3. It's irrelevant which order, and it's irrelevant which group, which numbers or variables get grouped together. It's going to equal the same expression as long as you're in addition or you're in multiplication. This doesn't work with subtraction and division. It's real important that we understand that. Just remember, addition and multiplication. And it makes sense. We absolutely know that 1 divided by 2 is not equal to 2 divided by 1. Those two are not equivalent. We can see that 1 divided by 2 is 1/2, but 2 divided by 1 is 2. They are reciprocals of each other, however. That's very interesting, but they're not equal. With addition, you don't have the problem that you do with division, or subtraction either. 1 minus 2 is not equal to 2 minus 1. 1 minus 2 is -1, and 2 minus 1 is 1, and -1 is not equal to 1. But it does work with adding, and it does work with multiplication. Okay, that's the essential review I wanted to get to before I get to the distributive law. We will get to know all of these like the back of our hand simply through practicing, right? It's not like there's a ton of difficult memorizing. No, this actually just makes logical sense based upon what we've experienced in life already, hasn't it? That's kind of nice. In fact, it's really nice. Okay, let's look at an example of the distributive law. We have an expression 5 times 4 plus 8. We always do what's in parentheses first, right? The parentheses give us the indication of what is the most important. So this is essentially 5 times what's 4 and 8 is 12. That simply equals 60, right? With the expression as you'll find it written in a lot of places, 5, when you have a numerical coefficient, that is a simple number, next to a group of numbers or a group of variables, this simply means multiplication. If it's going to mean anything else, there will be the different sign between what is grouped and the extra number. Or if you have, and we will get very good and used to all of these, we now know that once we solve what's in the parenthesis in this group here, this entire answer is going to be subtracted from 5. It's going to be 5 minus whatever this is. This is going to be 5 plus whatever is in this group. So when we see without any signs a numerical coefficient or a number on the outside of parenthesis snuggled right up next to it, that's going to be a multiplication. Okay? That's the conventional understanding. They will distinguish if they want you to add or subtract. And that's kind of nice to know. It keeps things simple, right? So, in this instance we have 5. I put the multiplication there on purpose to show you that, plus whatever's in this group. In this instance, for the distributive law, what we do is we take this 5 and we multiply it, we distribute it to each term in the group. We take the 5 and we distribute it with the 4, and then we take the 5 and we distribute it to the 8. So what this expression now means is 5 times 4 plus 5 times 8. And when we work this out, 5 times 4 is what? 20. Plus, we keep our same sign that's in the group of parentheses out here. But 5 times 8 is what? 40. Do you notice something? 20 plus 40 is 60. It's the same answer as this top one. This is the idea of the distributive law. Why this is so critical is I will show you here in just a little bit. I want to practice a few of these, and then I will show you the inverse operation that freaks students out, and it did me too. Uh-oh. Ta-da! I just broke the presentation board. Hang on, I'll be right back. The distributive law works well with numbers or with variables, it is the exact same principle. A times B plus C. We distribute A to the B, we distribute A to the C, so that this equals A times B. We keep the sign in the group, plus A times C. So it works with variables, it works with numbers, it works with all sorts of expressions. If we have 2 times x minus 3, we distribute that 2 into each term in the parenthesis, so this becomes 2x. You multiply 2 by x, and then minus 2 times negative 3 is 6. Is negative 6. That's the negative 6. 2x minus 6 is how to distribute that 2 into that. It's not too difficult, is it? It works in a combination with numbers and variables, numerical coefficients, as well as variables. 8 times a plus 5. We don't need to know the value of the variable in order to solve this equation. 8 times a equals 8a, plus 8 times 5 equals 40. And there's our expression. It's that simple. It works with fractions. It works with exponents. It doesn't matter. 2/3 times p plus q plus r. We distribute the 2/3 fraction into each one of the terms. Whether they would be variables, numbers, etc. is irrelevant. It all works out to where it's 2/3 p plus 2/3 q plus 2/3 r. And that's your answer. You're simply putting this one with this one, this one with this one, and this one with this one each way. And that's your full answer. So this is nice to see how the distributive law works with expressions and groups of expressions and groups of numbers. It doesn't matter whether it's variables or letters. And we want to practice this quite extensively because of its value for helping us solve really tough equations. 4 times 5 minus 3. It gives us excellent practice. 4 times 5 is what? 20. 4 times negative 3 is what? Negative 12. You can virtually invent these all day long to help you practice and get comfortable with it. All you have to do is change the numbers. You can make the 4 into a 3, the 5 into a 6, the 3 into a 2, and do it all over again. 3 times 6 is 18. 3 times negative 2 is negative 6. It's that easy. You can change the numbers again to 6 times 9 plus 4. 6 times 9 is 54, plus 6 times 4. Remember, there's no sign here, so we're multiplying this term by each one of the terms in the parenthesis. So 6 times 4 is a positive 24. And it's that easy. You can practice the subtract, multiply, add, and divide. You can practice it with numerical coefficients or variables. You can get to where you can absolute master this basic algebra property. And my serious suggestion is that we do so. That's why I'm going to practice a lot of it with you. I think I've done enough of those to show you the idea here. I've done that one. Oh, it works also with negatives. Negative 2 times, I even put the times in there. Negative 2 times 5 is negative 10. Negative 2 times negative 3 is positive 6. And negative times a positive is a negative. And negative times a negative is a positive. This will help you practice your signs, right? That's very important to do. If you have 5 times 2 minus 7. You can do what's in the parenthesis first if you so desire, so that this becomes 5 times, what's 2 minus 7? Negative 5. So that equals negative 25. A positive 5 times a negative 5 is a negative 25, right? So you can practice all sorts of ways of working on this. Oh, let's do a combination here. I deliberately made this one so that I could show you a combination. F minus 6 plus 3. Yeah, now this shows you how you combine both the numerical coefficients as well as the variables. You simply multiply them together. 4 times F. This is 4F minus 4 times 6 is 24 minus 24. 4 times 3 is positive. 4 times positive 3 is positive 12. And there's your answer. 4F minus 24 plus 12. It's really, truly not that difficult. If we, instead of having a coefficient out here and 2 terms in a parenthesis, what happens if you get a lot bigger terms in the parenthesis? Well, let's see it. 11 times 2m minus 3n plus 4r minus 6z. And you say, holy cow, I can't do that. There's too much there. No, you can do this. Watch. It's the same principle. If this group stretched out to 3.5 miles down the road, it's still the same thing. You simply distribute the outside term to each term in the parenthesis every time. And that's a z, that's not a 2. It sometimes helps to put a little bar through your z so you don't get confused with whether it's a 2 or a z. So let's do this. 11 times 2m is 22m. 11 times negative 3n, 11 times negative 3 is negative 33n. 11 times positive 4r, 11 times 4 is 44r. And 11 times negative 6z. 11 times negative 6 is going to be negative 66z. So it doesn't matter if there's only 2. You distribute this to the 2. If you have 3 terms within the parenthesis and an outside number, you distribute that outside number to each individual 3 terms in the parenthesis. If you have 53 terms, do it to all 53 terms. It's that simple. There's nothing complicated about this distribution, but it is a very important property. It works the same way when we have to deal, and we will have to deal, I guarantee you, it works the same way with fractions. Let me show you fraction. We have 2/3 times e plus 1. You go, really? Well, after seeing those last few, this is a piece of cake. You can do this in your sleep, right? 2/3 e. 2/3 times e is simply 2/3 e plus 2/3 times 1. And we know that any number times 1 is just equal to that number. So we don't even have to write the 1. Multiplying that out, 2/3 times 1 is simply 2/3. So it's 2/3 e plus 2/3. See, there's nothing to be intimidated about with this. Oh, and here's another great idea here. If we have a negative out here, and we have a y minus 3x plus 9b, you simply distribute this number into each term in the parenthesis. Negative 6 times y is negative 6y Negative 6 times negative 3x is positive 18x. Remember, a negative times a negative is a positive. Tell yourself this a trillion times until you can just simply do it. We do it with the English language in order to talk and write. Do it with mathematics. Math is the language of science. Negative 6 times positive 9. A negative times a positive is a negative 54b. And that's all there is to it. You have distributed this negative 6 successfully into each term in that parenthesis. And you don't have to keep the parenthesis once you do the distribution. There is your answer to that equation. And you look at that and you go, well, that equation doesn't look so difficult now. No, it really doesn't. That's part of the point. They may look complicated, but when we know what to do, when we familiarize ourselves with these, they really aren't that big a deal. And if we have a negative 3 multiplied by x plus y minus z plus 4n plus 3x minus 7f, you go, holy schmoly, there's too many in there. No, there's not. As however many there are in this, this is what you distribute that number into each single term. You keep the signs, or you change the signs if you have a negative times a negative, right? Or even a negative times a positive. Let's see. Negative 3 times x is going to be negative 3x plus negative 3 times y is going to be negative 3y minus negative 3 times negative z. A negative times a negative is a positive, so that's going to be a positive 3z. Negative 3 times positive 4n is going to be a negative 12n. Negative 3 times 4 is negative 12. A negative 3 times a negative 3x is a negative 9x, and a negative 3 times a negative 7f, a negative times a negative is going to be a positive 21f. And you go, oh. Yeah, take a deep breath. However, congratulations, pat yourself on the back. Check this out. You solved one great big long hairy looking equation, and it actually really wasn't that difficult. You didn't have to come up with any new subtle difficult math at all. You simply plug and chug and multiply and make sure you keep your signs correct. That's all there is to this. That is distribution. This also works when we do, I think I've got enough time for one more. At least I hope I do. If not, sorry, I'll have to cut this one off. Let's say we're given 1/2 times 1/3 n minus 2/3 m plus 3/4 h plus 7/8 s. And you look at that and you say, no thanks, dude, I think I'll take a pass. You're throwing too many fractions at me, man. No, relax. Look, it's simple to do fractions. We've already been practicing fractions. You will, I guarantee you, if you're going into chemistry, if you're going into physics, if you're going into mathematics, if you're going into engineering, etc., trust you me, man, you're going to be dealing with fractions the rest of your life. So let's get them down now. What is this essentially telling us? We are multiplying, right? To multiply fractions, 1/3 times 3/4 is the easiest operation. We don't need a common denominator. We simply multiply straight across with the numerators and straight across with the denominators. So this is 1 times 3 is 3, and this is 3 times 4 is 12. And then you reduce it. 3 will go out of 3 once. 3 will go out of 12 4 times. That's simply 1/4. You can fall off a log with more difficulty than doing this. So what is 1/2 times 1/3 n is 1/6 n. What is 1/2 times negative 2/3 m? Well, 1 times 2 is 2, and 2 times 3 is 6 m. What's 1/2 times 3/4? 1 times 3 is 3. 2 times 4 is 8, and we've got the h variable. What is 1/2 times 7/8 s? 1 times 7 is 7. 2 times 8 is 16, and we carry along our s. So the answer to this long, hairy fractional situation is really simple. It's 1/6 n. Now notice this, the 2/6, this can be reduced, can't it? We can take a 2 out of the 2 and leave us 1, and a 2 out of the 6th and leave us a 1/3. So 2/6 m becomes 1/3 m. You always want to reduce your fractions into simplest terms. So we have 1/6 n minus 1/3 m plus 3/8 8 plus 7/16 s. Now see, did you break a sweat in your brain doing that? No, you simply multiply the numerator, multiply the denominator, and ta-da, you're there in Math City. Piece of cake. So this is what I wanted to show you this time. And we have a very important and absolutely eye-opening video next time. I wish, and maybe they did, you know, I don't know, but I think the system that I came up through was more interested in getting you through a certain number of chapters rather than helping you understand what the heck, right? I think a lot of you are in that same boat. Today it's changing somewhat, but if I would have been shown in school what I'm about to show you in the next video about distribution, it would have enormously simplified my math problems. It would have saved me a lot of math headaches. So I'm looking forward to doing this next video with you. Happy calculating. Have a great life. If it's late at night and you're watching this, shut this thing off and go to sleep, you silly goose. I'll see you in the next video.